So here we go. I'm just going to do problems exactly like I did in class. The only difference is instead of being in the classroom, it'll be in the form of a YouTube video. So we're finishing up 3.4 is where we left off at. We're going to work backwards on this one. So we're going to have a polynomial that has three particular roots to it. It tells me that 2 and 2i are zeros. And the other piece of information that tells me that if we evaluated f of -1, we would get a value of -45. So we were trying to come up with a polynomial that meets that criteria. So first of all, we have to remember that where we have a polynomial, it's going to be x. We'll get that up already. How about x minus n1 and x minus n2 and x minus n3? So there we have a polynomial that's going to have three specific roots to it. Okay. It will equal f of x essentially. So we know that we have those roots. It tells me that 2 is a root, so we'll have x minus 2 as a root. It tells me that 2i is another root, so we're going to put a 2i in there. And with imaginary roots, since it's imaginary, its conjugate will also be there. So it'll be x minus a negative 2i, which turns out really into x plus 2i, but we'll get there later. So what we're going to have to do is basically we're going to FOIL this out, or we're going to multiply this polynomial out. So first of all, we'll go with these two, since these are going to end up being x minus 2i and x plus 2i. So those, again, end up being the conjugates like we talked about. So when we multiply those together, x times x gives me that x squared. We're going to have a 2ix on the outside. The inside gives me a negative 2ix, and then the 2i times the 2i gives me a negative 4i squared. And this is where I have to remember that I squared thingy. I squared is -1, so a negative 4 times a negative 1 actually turns this into a positive 4. So I am left with the x squared. The 2ix and negative 2ix are going to cancel, and then negative 4 times negative 1 is a positive 4. So all of that turns into x squared plus 4, and we still have x minus 2 sitting out here. Again, we're trying to come up with that polynomial, so we're going to have to multiply it out one more step further. So x times x squared gives me an x cubed. X times 4 gives me a 4x. Negative 2 times x squared is a negative 2x squared, and a negative 2 times a 4 gives me a negative 8. I'm going to write this in descending order, so we have x cubed minus 2x squared plus 4x minus 8. So one would hope that we had a polynomial done already. However, there could be, and I didn't write it in here from the very get-go, there could be an a in front of this. Okay, so that means there could have a constant in front of that function, which we don't know about, and that is why they gave us this last piece of information. We know the value of the function at -1 is -45, so there's what we're going to roll with. We're going to put a times, we're going to put that a in there now, -1 cubed minus 2 times a -1 squared plus 4 times a -1 minus 8. We know that this value is going to equal, back up to here, -45. So now we have to figure out what this value is. So we're going to have a -1. This is going to give me a 1 times 2, which is a -2. This is going to give me a -4, and this is going to give me a -8. So all told, we have a -15 equals -45. Now that doesn't look very nice, so I'm going to rewrite it without the bracket. -15a equals -45. So that means that a is equal to 3. And now that we have that constant, we know that constant gets multiplied by my entire polynomial. Here, we'll put it in there too. And so that means that my polynomial is 3x cubed minus 6x squared plus 12x minus 24 is my polynomial. Okay? So, yeah, it's a lot of work. I myself particularly don't appreciate this problem at all, to be blunt. However, it does appear on our final. So we need to go over it since it appears there. So that was number 6. Number 7 is it's very, very similar to it. It works a little bit differently because the number is more, it's a complex number versus an imaginary number. So we're going to hit number 7 here, and then that will end. We need for 3.4. So here we go. Here is number 7. In number 7, I know it's going to be a 3-termed polynomial again. it gives me roots that are -3. 1 is going to be 4 plus 4i, so that means the other one has to be 4 minus 4i. And then it also tells me that f of -1 is equal to 82. So there's what I have to work with. So again, we go back to, we know that the function is going to be in this form. We're going to have roots of n minus, man, how have I goofed that up 2 problems in a row? X minus n1, x minus n2, and x minus n3 is what we're going to start with. So, and I'm going to drop the a out of here just because that's just, I think it just muddies up the water. So we're going to roll with x minus a -3, x minus 4 plus 4i, and then x minus 4 minus 4i. Okay, so this one is a little bit more cumbersome up front because we have a trinomial. We're going to go with a trinomial, and actually makes the whole multiplication more cumbersome, but we can work through this. There's x plus 3. We know we're going to distribute the negative sign, so that's x minus 4 minus 4i. And then over here on the other one, that's going to be x minus 4 plus 4i. And again, we're always going to start by multiplying our 2 imaginary parts together, so we're going to multiply these 2 together. X times x is x squared. X times 4 is a -4x. And x times 4i gives me a positive 4ix. We'll keep the multiplication going. -4 times x is a -4x. I'm going to move it down to another row so I can just match up my terms. -4 times -4 is going to be a positive 16. And a -4 times a positive 4i gives me a, oh my gosh, -16i, if I could think. And then lastly, we're going to distribute the -4i x times, -4i times x is going to give me a -4ix. And again, I'm lining things up vertically. -4i times this -4 gives me a positive 16i. And then lastly, -4i times a positive 4i gives me a -16i squared. So now we are ready to collect all of these like terms. So we're going to have this x squared. We're going to have a -8x. My 4ix's are going to cancel. My 16i's are going to cancel. And I have to remember again that this is a -1. So -16 times -1 is actually a positive 16 that we're going to get together with this 16. And therefore we have a 32. And the fun keeps coming. Now we're going to drop down that very first one. So again, we're dropping down the x plus 3 and we're ready to do it all over again. Happiness. X times x squared is going to give me x cubed. X times -8x is a -8x squared. X times 32 gives me a 32x. 3 times x squared is going to give me a 3x squared. 3 times -8 is a -24x. 3 times 32 is going to give me a 96. And so we end up with x cubed minus 5x squared. Can you think today? How about a positive 8x and a positive 96? And one would hope we were done with our polynomial. However, we have to remember that this a was sitting up here, so that is going to carry all the way down here. So we have a times that polynomial, and that's where we got to continue with. So we know that if I substitute in a -1, I'm going to get a value of 82. Since my constant was 96, we might get lucky here, and we don't have to have a constant, but we have to figure it out. So here we go. We're going to have -1 cubed minus 5 times a -1 squared plus 8 times a -1 plus a 96. And we know that this product, all of this is going to equal an 82. So we end up with a times, we'll just write this out, -1. -1 squared is 1, so it's going to be a -5. This is going to give me a -16. And then we're going to have this positive 96 at the end here. All right, so that's going to give me a -6, -22. So that means that we're going to have a 74. equals 82. And I don't like this because this should come out to be an even number, so I'm going to guess somewhere I made a mistake. So I can find it quickly, or else I'll just have to redo the whole video. And I can't ask you guys for help. Okay, here we go. I actually took -1 times 8 and got -16 out of that, so I found the error. That probably took way too long, so back up the bus here. So that's -14, so sure enough, there we go. Wow. Hopefully you guys found that faster. I was just about to give in and give it up, but a is equal to 1, so all that means is we get to go back to the very original, this guy right here. My answer is going to be, slide this up a little bit, x squared minus 5x squared, x cubed, excuse me, plus 8x plus 96. Ouch, I'm sorry. Well, at least this video was short. All right, I'll be back for 3.5 in just a second.